Hello, this is Mark Anderson for Kellogg Community College, and we're about to do the infamous problem number 12 in Chapter 3, Section 2 of your homework. And the reason why I give this problem every single year that I've been teaching this course is that it has a very key question. This looks at two sets of data. According to the book, these are starting salaries of teachers in two different continents, one in Europe and one in Asia. And what they say in the last sentence is, which set of data is more variable? And this is the perfect question to actually talk about CVAR. And CVAR is actually not covered that much in the homework, but this is a great place where we can compare two standard deviations and look at the variability between them. So we're about to do two sets of data which require two standard deviations. You'll note that I'm actually not going to use the formula. The formula, which your calculator can actually do much quicker than you can, is nice and all, but I would much rather you derive or see where the components of the formula is actually getting created. So what I'm going to ask you to do on the test is what I asked you to do in the notes, which is create tables. So here we have our first set of data, and our first set of data looks at the starting salaries in Europe here, and step one, which I will put here in this first column, I will put underneath here. This step one right here is going to be to find the average of these. Now I've actually done some of this work outside of this problem, so I've added up these 7 pieces of data and I've divided by 7, and what that gives me is an average of $34,637. Now, I am going to just draw an arrow here for my first column because for my second column, or part 2, is I'm going to look at the difference between these two. And I know that some books talk about absolute difference, and some of them do the difference and put in positives and negatives, but since I know that my third column is going to square these, I just subtracted them and just kind of ignored the negative signs. So you might have different books asking for different things or different professors asking for different things, but I'm just going to think of the absolute value difference between these two numbers. And here the difference would be $14,067. And then between $41,000 and this amount, $34,000 approximately, is going to be $6,807. And if we do this, $4, not 7. And so if we kind of go down the list here, I'll just kind of ramble on with the numbers that I received, which is $1,958, $2,501, $4,253, $5,311, and then finally $6,848. So again, to repeat, what we've done is we found the average of these 7 numbers, we made a column of that, and then we basically subtracted the differences between these. And what I did is took the absolute value, which is the positive value of each of these differences, so all of these are positive. Now, for the third step, and this is where the numbers get really big and you're going to have to, be a little meticulous here, you are going to square these numbers. And since these numbers are already in the thousands, or in this one case tens of thousands, when we square it, we're going to have a number that's gigantic. 197,880,489 is $14,067 squared. And we just keep going down the list. 46,294,416. And if you're doing this in the table on the calculator, you'll have to actually scroll over the number to see the full decimal instead of scientific notation. 3,833,764. And then it's $6,255,001. And then it's $18,088,009, $28,206,721, and finally $46,895,104. So this gets us the average of all the salaries, the difference between the data point and the averages, and then these are the squared differences. Then what we have to do for step 4 is add these up. Now, I promise you on the test that the numbers will not be this big, but this is a good strategy this is good practice to get you used to smaller numbers, because if you can do the big data set here, you can do the small data set. Adding these up carefully, you get a total of 347,453,504. That's the sum of all the differences squared. So, what's next after that? Well, since we are under 30 data points, we're going to divide by n minus 1, which happens to be degrees of freedom, which we're going to talk about later. But taking our total here, that $347 million, 453,504, and dividing that by n minus 1, which is 6. Now, to tell you what the n is the number of data set pieces. We had 7, so we divide by n minus 1, which is 6. Then we get an answer of $57,908,917.33. And I am rounding it to 33 cents because we're talking about money. That right there is our answer to this division. And so for step 6, we take that and take the square root. This is a little note here. Since we squared all the differences, taking the square root is kind of getting it back to size. This number, by the way, as a little side note, this number before we took the square root is also known as the variance. So if you're curious, if you look at any solution manual, they will say that the variance is 57. This number, $57,908,970.33. But once you take the square root, the answer under blank number 7 is the standard deviation, $7,609.80. Now, of course, depending on if you did any rounding here, you may get something slightly different, but this right here is the standard deviation. Now, one component I also ask on my tests is that you draw a normal curve and show where this data, or how this data looks on a normal curve and compared to its norm or average. So the norm salary is going to be the average, which was $34,637. Now, I want you to go 2 standard deviations in either direction, and let's remind ourselves here the standard deviation was $7,609. I'm not going to count the 80 cents. If you wanted to use $7,610, that would be fine as well. So what I'm going to do now is take my norm, my average. I'm going to now add the $7,609, so I get a total of $41,246. And I add another 7,609, and I get 48,855. All right, so now I'm going to subtract that 7,609 from this and get $26,028. Subtract another 7,609, and I get $1,840. Now, to reinforce what a normal curve is roughly 2/3 of the data, a little bit more than that actually, but roughly 2/3 of the data is within 1 standard deviation away from the norm. This first standard deviation in each direction replicates normality. So if your school basically started you between $26,000 and $41,000, then you were considered normal. And actually, that's, if you look at the data sets here, yeah, that's actually good. Looks like the schools are paying within the normal range according to these 7 data points. Now, obviously, anywhere beyond this line is going to be considered abnormal, but on the good side, I mean, this second standard deviation is in the top 5%. So there's one school that's in the top 5, like right near to the top 5% of all paying schools. And luckily no one's down here in the bottom 5%. But this is the normal curve based on the fact that most of the normal ranges will be around here. Now, we're going to run the CVAR at the very end of this, once we have all of the data in front of us. So let's actually look at the next set of data. Let's go to Asia, and let's look at their starting salaries here for their teachers, according to the book. So the first thing we're going to do is we're going to add up these 6 numbers and divide by 6. And in doing so, we get $16,281.33. Now, if you've done this problem ahead of me and you kept the 33 cents, that's fine, but you may not have remembered in class where I said, look, if you're going to make this problem easier on yourself, you may want to just round it to the nearest whole number. And by taking off the 33 cents, we're not actually going to change the problem drastically. In fact, the standard deviation will be the same if you use technology versus by hand. But for the by hand motion, let's actually just drop the 33 cents and look at the base salary, this step 1 here, this average salary being $16,281. So let's now look at the differences between the two in step 2 here. So we're going to subtract these two, and that gives me $10,571. Subtract these two again, this minus 16,000, we're going to get $7,202. Subtract these, and we're going to get smaller numbers here, $1,966. Subtract here, we get now a negative number, but again, I'm going to ignore the negatives. I'm just going to consider these positives, so it's going to be $2,634. Subtract this, I'll go to another negative number, kind of ignoring that. $6,694. Subtract here, subtracting from the $16,000, we're going to get a total of $10,419. So these are all the subtractions, and then we're going to square these differences. And unlike the last problem, these differences won't be as big, but they still do get big. Like the first one here is $111,746,041. I got to make sure not to say dollars before I'm done with the number. $52,012,944. We square the 1966, and we get $3,865,156. Squaring the 2,634 gives us, let's see here, just making sure I'm lining up here, $6,937,956, and then this makes $44,809,636, and finally, our last really big number that gets squared is $108,555,561 by squaring each of these numbers and using the square key or just multiplying by itself on the calculator. For step 4, we're going to sum all these up, and in doing so, we get 327,927,294. There we go. That is the sum of all the differences squared. So again, we found the average, difference of all the average, and then squared all the averages. And here we are at number 4. Okay, so what do we do next? Well, we take our result in number 4, that for step 5 here, we're going to take our 327,927,294 and divide by 5, or n minus 1, which is 1. And this is because we have a data set under 30, and we're accounting for something called degrees of freedom that we're going to learn about later. And this gives us an answer of 65,585,458.80 cents. All right, so there we go. And that is our step 6. This is our variance, and we're going to take the square root to find our standard deviation, which is 8,000. This is our answer here, $8,098.48. This is the standard deviation of our data set. So now that I've written all that down, let's actually go take a look at the picture. So if we go take a look at the picture, we're going to have our normal curve, and you'll have to draw one of these on the test. I'll have a number line for you just to kind of prompt you to do so. Alright, so there's your normal curve, and we found that the average salary was $16,281. And then one standard deviation was marked by 8,098. And again, I'm not going to use pennies here because it just doesn't make sense. So, I mean, we're not going to really see that big of a difference on our normal curve. So we add this $16,281 and this together, and we get a total of $24,000 $379. Add another $8,098 to that, and we get $32,477. Subtract the $8,098 from this value, we get about half of that, $8,183, and subtract another $8,098 from that, and we get $85. So this is the average salary, and this first standard deviation away from the norm in either direction is going to be what's considered normal. And if we take a look here, it looks like we've got normal, 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 normal. Okay, so the top number and the bottom number are not in that normal range, but that top number doesn't ever eclipse that top 5% like it did on the other data set. That's good to know. It's somewhere around here, and this bottom number also is between the first and second standard deviation below the norm. So here we have a lot, can kind of see just with a gut check, you can kind of see that, hey, it looks like this is varying more than the other data set. But that last question that says, which looks more variable, you have two standard deviations that look almost identical to each other, and let's actually now kind of answer that using the CVAR. So let's kind of get to a blank screen. So let's kind of remind ourselves what we found here. So if we looked at the Europe, according to the book, Europe's average was $34,637. So that was our first data set. Our second data set's average was $16,281. And, there's so many different variables according that would mess with that, cost of living and scale of environment towards the dollar, because this is all scaled against the American dollar, so currencies are definitely not all created equal. So obviously we're looking at, some differences here. But then now let's look at the standard deviation. If we look at the standard deviation of the first data set, we found that was $7,609, and the standard deviation of the second set was $8,098. And I've had people say, without actually running CVAR, it looks like this is varying more because it's 400 more than this. But that's actually just scratching the surface. I mean, yeah, it is 400 more than this, but look at its average that it's compared to. I mean, we just drew two normal curves, but you don't actually see the magnitude of the differences here unless we run the CVAR. And the CVAR formula is pretty simple. The CVAR formula is taking the standard deviation and dividing it by the average of the data set. So if we do so here, if we take our standard deviation and divide by the average, the percentage of variation is going to be rounded to 0.22 or 22%. So its percentage of variation, I mean, it isn't zero, there is variation, but it's also around 22%, so that's not so bad. Now let's look at this here in comparison. And by the way, 22% could be viewed as bad, but I'm just for comparison feel like, the variation of salaries are going to exist everywhere, so 20% variation, I guess I'll consider that okay. But let's now look at this. We have the same, look at that, $400 difference out of thousands. That's not too far away, but when you compare that to the average, you can see that there is a huge difference here where the differences aren't that big here, and if you divide the two, you get an answer of 0.497, or roughly 50%. And that is a lot more variation than this, almost, actually not almost, but a little bit more than double the variation. So you have the the real focus of the CVAR is to show that, hey, we actually just can't look at the average. We also just can't look between two groups at the standard deviation, because look, the standard deviations are pretty close. What we have to do is we have to look at the standard deviations in relationship to the averages to see which one is really varying more about the average. And you can see that if you're in this continent, there's going to be a lot of variability in your salary versus this continent. And so that's the reason why I do problem number 12, because problem number 12 really hones in on that very well. And that is quite the gauntlet, because I think if you also can do problem number 12 and do it pretty well without a lot of help here, even though this is a really good walkthrough, you can do whatever's on the test because it's going to be much smaller and much easier to compute. Thanks again for watching. That's a heck of a problem, right? And luckily, it's your only one that deals with all of these concepts twice in one. But there are other standard deviations on the homework. Make sure you do those in the table method as well so you're prepared for the test. Thank you for watching.